Welcome to our review day for Unit 4. Last time I recorded a video, it was a screen recording, and a fire broke out in the media center while I was recording it. So hopefully that will not happen today from the comfort of my apartment. Now, this video specifically is to be watched if you miss the in-class review. So if you are absent on the review day and you obviously want to try to take the test on time, this video will give you a good solid review before you head into test day, or if you need to retake the test. Now, if you're doing this for a retake, then you will be required to turn in your work as evidence that you've reviewed before being allowed to retake your test, okay? So keep that in mind. So make sure that you have paper out. You may or may not have a solid copy of the review sheet that we use in class, but if you don't, then you need to have some notebook paper. So pause the video right now if that applies to you, and make sure that you have everything you need to show me that you have prepared and reviewed before you try taking the test again, okay? All right, so without further ado, the way that I structured this was that we would make up some polynomial expressions in class. So the idea behind that was that not everybody's going to have the exact same review, that we kind of be flexible with it. And so for the purpose of this, I'm going to make up some polynomials. Now, in the actual review, it says like the first one should be cubic, and I can't remember if I changed the second one to linear or quadratic. I think I kept it as a quadratic. So today, the day that I'm recording this is January 16th is the day that I'm recording this, 2023. So I'm going to make up a polynomial just with the dates. So that's 1x to the third plus, we'll just say 1x squared minus 6x plus 23. Okay, so that's 11623 in case you're wondering about the coefficients there. And the second one should be a quadratic. So I will pick, what will I pick for the quadratic? I don't know. We'll pick my sister's birthday. So we will do 10x squared plus 28x minus 81. Okay, so my sister's birthday is 10/28/81. So anyway, okay, so those are maybe bigger numbers than we'd like. Why did I do that? I have to multiply these things together. Onward. Okay. So on your own, use a separate piece of paper to perform the following. So we're going to take expression 1 and add to it expression 2. Okay. Oh, I need to make sure that I write these down because I did not put them on the next slide. 10x squared plus 28x minus 81. That'll show me. I should have done my brother's birthday. My brother's birthday has lots of ones in it. Okay, so adding them together. So to add these guys together, you simply combine like terms. So we have x to the third plus x squared minus 6x plus 23. And we're going to add to that 10x squared plus 28x minus 81. Now, you are not required to show work for the adding problems because it is entirely possible that you can add these things in your head. And I promise I will not on your test give you numbers like 81, okay? Just because that's me. Now, looking at this, we should be able to see that there's an x to the third, but there's no other x to the third. So the x to the third just comes down as is. Now, when it comes to the x squareds, I have positive x squared plus 10x squared, which is going to give me 11x squared. I have negative 6x plus 28x. So 28 minus 6 is 22, so that'll be 22x. And then this is fun, positive 23 minus 81. So that's essentially it's going to be negative because we're subtracting the bigger number. So I'm going to do 81 minus 23, and that gives me 58, and it will be negative 58. Okay, now if you're wondering why I'm turning to the side, I'm using my cell phone as a calculator here. Using my cell phone as a calculator. Okay, now for the adding, you don't need to show anything. You also are not going to be required to show anything for subtraction, but I discourage you from that. I do encourage you to show at least one step. So on your test, you're going to have your polynomials, and we're going to be subtracting them. And what I strongly encourage you to do is one middle step right in here. So we'll do x to the third plus x squared minus 6x plus 23. But remember, the most common mistake with subtraction is not distributing the negative. So I highly, 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 highly recommend that you do a middle step here where you distribute the subtraction. So it'd have minus 10x squared minus 28x, and then when we subtract something that's already being subtracted, that minus a negative becomes addition. Because it's so easy to make that mistake. Okay, it's just so easy to look across and see the plus 28x, and so you're like, oh, negative 6 plus 28, and you get the 22. Okay, so what happens is that students only end up subtracting that first term, and then everything else is actually being added. It doesn't take hardly any time at all to do that middle step. If it's homework and it's a low stakes, and you can get away with not doing it. But when it's a test and it's higher stakes, it's worth it to take the time. Okay, so as with before, the x to the third is a lone ranger. This time we have positive x squared minus 10x squared, so that's going to give us minus 9x squared. And we have negative 6x minus 28x, so minus 6x minus 28x. I don't know why, for some reason in my head that's sounding weird. So what is that? 34. So minus 34x. And then positive 23 plus 81. So this is when your teacher's too lazy to go get her calculator. 104. Plus 104. And like literally my calculator, my phone anyway is sitting right to my left here. I just don't want to bother. Okay, now, so hopefully I did all that correct. If you're like, sure, I made a mistake, yeah, sitting here and I'm too lazy to do something on my calculator, so it's possible. So anyway, let me know if that's the case. But there's your addition and there's your subtraction. Again, on the test, you're not required to show work for these two, because it is possible, especially with smaller numbers, that you can do them in your head, and I'm not going to penalize you for that. However, multiplication. So this is where I just kind of kick myself, like, why am I picking these numbers? But I believe in following through with your silly decisions. So to multiply them, we're going to need a fairly big area model. And then across the top, I'm going to have x to the third plus x squared minus 6x plus 23. So we have 4 columns there. And then down the right, we have 10x squared plus 28x minus 81. Well, that's fantastic. So make sure that you are allowing yourself plenty of space. And essentially, we're going to multiply everything through here. I will absolutely be using my calculator for this. And then we add up all the little areas to give us the area of the whole thing. So just as a quick little aside, if I have to do 10x squared times x to the third, which would be that first multiplication, okay? 10x squared is 10 times x times x. X to the third is 3 x's. So as you can see there, I have x times x times x times x times x. That is 5 x's being multiplied together. So this will be 10x to the fifth. That is scratch work up here, okay? That's like the little work that you do off to the side if you aren't sure how something should look. I do not grade scratch work. I do not even look at it. Going over to the next one, we have x squared times x squared. Well, if you have 2 x's and then you multiply 2 more x's in, you end up with 4 x's. So this would be 10x to the 4th. 10 times negative 6 is negative 60. And this gets into a little bit more comfortable territory. X squared times x, that gives you 3 x's. And then this is lovely. 10 times 23 is 230. And that is x squared. Oh, this is awesome. All right, next line down, we have 28x times x to the 3rd. Well, x times x to the 3rd is going to give me 4 x's total. So this is 28x to the 4th. And then 28x squared, well, x times x squared is going to give me 3 x's. So this is 28x to the 3rd. Now, here's where I can do that in my head, because you can do 20 times 6 plus 8 times 6. So what is that? 120 plus 48, so 168. But I'm going to double check it. So 28 times 6 is 168. Yay for mental math. But again, like on a test, I would not risk doing that in my head. I can, but there's just, you got to keep in mind of like what's at stake. So this is going to be 168x squared. And then this one, I'm not even going to bother because by the time I sort it out in my head, yeah, this is going to be 644x. And I did not do that in my head, in case you're wondering. That is, I did do it out on my calculator there. All right, so negative 81 x to the 3rd is just, times x to the 3rd is just negative 81 x to the 3rd. Negative 81 times x squared is negative 81 x squared. 81 times 6 is 80 times 6 plus 1 times 6, so 486. 81 times 6, 486 on a roll. And a negative times a negative is a positive, so that will give me 486x. And then 81 times 23, which is 1,863. And while I'm doing this, just as an illustration, this is why on tests, like if you do enough practice problems, like if you do the work that we give you in class, if you do the work that's on your homework, you're not going to be super surprised by what you see on a test, because we don't pick numbers like this for a test because it makes it unnecessarily complicated. So generally teachers won't do that. It's another incentive for making sure that you do your work. Now, to get the final answer, we do need to add all of this up, and as advertised with the area model, your like terms are going to be on those diagonals as long as we haven't skipped any terms in the original problem. So we have the 10x to the 5th, that's our Lone Ranger. Then 28x to the 4th plus 10x to the 4th, so that's 38x to the 4th. Now, I am going to bust out my calculator for these just because it's a little bit too much to hold in my head. I'm going to start with the positive 28 and then subtract 81 and subtract 60, and I get negative 113 x to the 3rd. And I'm going to do these ones on my calculator as well. So we have 230 minus 168 minus 81, which gives us negative 19x squared. This one is 644 plus 486. Lovely. 1,130x. And then, of course, that's our Lone Ranger down there. Okay, so, phooey on me for picking such awful numbers. You won't see stuff like this on your test. If you have a teacher that does that to you, they're just either being lazy or mean. I don't know why you would do that. But notice that math is consistent though. So just because the numbers are awful, it doesn't change how the problem works. It doesn't change your strategy. It doesn't change the principles, which is why we always focus on those principles and the key ideas, not on shortcuts like what's the fastest way for me to get to this answer, okay? Because we want something that's going to work even when the problem is messier. So there's that problem. I promise the rest of this is not that bad. So for the division, this one, I did not want to go with just problems we would make up on the spot. Because if you think that multiplication was bad, when you make up polynomial division on the spot and you're not methodical about how you lay it out or what you do with the numbers, these can get absolutely beyond atrocious with like fractions inside of the problem. They can get really, really awful. So this one I have provided for you. So we have 3x to the fourth plus 10x to the third minus x squared minus 9x plus 6 divided by 3x plus 4. So setting up our area model, you look at that highest exponent, that tells you how many columns you need. And then whatever you're dividing by there, so in this case the 3x plus 4 tells you how many rows you're going to need. And then we start with our 3x to the fourth right here. And we ask ourselves, what times 3x would give us 3x to the fourth? Well, I got the 3 taken care of. Now I have 1x. In order to get 4 x's, I will need 3 more. So this must be x to the third. Then we multiply down here. So we will get 4x to the third down here. Now remember that whatever we have has to add up to this polynomial. So I need 10x to the third. I have 4x to the third, which means I need 6 more of them. So that were I checking this, the 4x to the third plus the 6x to the third would give me that 10x to the third. Now 3 times what gives me 6x to the third? Well, 3 times 2 would give me the 6, and then we've got 1x, we need 3, so the other 2 x's must be coming from up there. And then multiplying, so 4 times 2 gives me 8, and then of course we have the x squared. And now we need to do that thinking step again. I have another x squared here on the diagonal. They have to add up to negative x squared, which means that this must be negative 9x squared. So that when I combine those, negative 9x squared plus the 8x squared, I will get that negative x squared. 3 times what would give me that negative 9? Well, that would be a negative 3. And then we need x squared. We have one of them over here, so the other one must be coming in from the top. 4 times negative 3x will give me negative 12x. And now we need to do that thinking step again. I have negative 12. I need a negative 9. So what being added in right here would give me the negative 9? That would be a positive 3. And of course it's a 3x because we're on that diagonal. 3x times what would give me 3x? Hopefully you know that's a 1. And 1 times 4 gives me 4. Now here's where you got to deal with your remainder. I have a 4, but I need a 6. What would be added in right here in order for me to get that 6? That would have to be a 2, and that is your remainder. Now make sure that you write the answer correctly, okay? So that you're not just filling out this beautiful area model. In order to answer the question would be x to the third plus 2x squared minus 3x plus 1 plus the remainder over the divisor. And there we go. Okay, now if you need more review than that, you should go back to your notes. Okay, you should have the notes Or if you were absent, there is a video where we develop this whole strategy, and there should be some Desmoses, which I can unlock. Those are not available for a grade, but if you'd like me to unlock them or reassign them for practice, we can do that as well. You should have also had, there was an extra credit assignment that was posted, and that should still be available on OneNote, where you can do some additional division problems, okay, to get some additional practice. All right. Now, for these, there are multiple ways that you can do these, okay? So we've got the way that we did it in class, and then I linked you over to another video because I've always taught sum and difference of cubes with a formula. And we call it at Atlantic Coast the SOAP sandwich. So you use SOAP to determine your operators, adding and subtracting, and then the sandwich part is square it, smush it together. So you can go and access that. On the in-class test, I do not care which way that you do it. All right. You will be provided with the graph if the graph is the way that you want to go about doing it. So for this review, I am going to be using the method that we used in class. So the method that we used in class, we would take x to the third plus 64. And what we're going to look at right there is the root or the 0. Okay, and this might make more sense now that we've covered a lot more with roots, zeros, polynomial functions, and so forth. So what we know is that x equals -4 is going to give us that y equals 0. So if I do -4 times -4 times -4, okay, raise it to the third power, that'll give me -64. -64 plus 64 gives me the 0, which it corresponds to the point over there. Now, what that means for us is that we take that x is equal to -4, and you are welcome to go straight to x plus 4. So if you are comfortable with that, go for it. If you're not comfortable with that, then you probably want to envision this, that you're adding the 4 to both sides, and then you can see the factor there. And then we do this with polynomial division. So we're going to engage what we learned in the last lesson, or what we reviewed in the last problem. So we're going to divide by x plus 4. And we start out with the x to the third. Well, what times x to the third gives me x, or what times x gives me x to the third? That would be x squared. And then we multiply, so we get 4x squared right here. Now here's where this is like easier. I don't have any x squared terms, so you don't even need to think about, well, what do they have to add up to? They have to add up to 0 because they're not there, which means that that automatically is going to be -4x squared. X times what gives me -4x squared? Well, that would be -4x. -4x times 4 is -16x. And of course, as before, there's no linear term, which means that whatever goes right here in my division has to balance out that -16x. That's got to be +16. So that'll be +16x. X times what gives me +16x? Well, that'll be 16. And then 16 times 4 is the 64, and I have my check. Now that is not your final answer. So remember that the directions for these are to factor. And so if you think about, okay, you've got your area and it factors into the base times the height, your final answer needs to be in the form of factors. It can't be sitting there on that model. And so for your final answer, you would say one of the factors is x plus 4. And we got that from over there on the graph. We're basically using that to find one of the factors. The other factor is going to be the width of that rectangle, which is x squared minus 4x plus 16. On your in-class test, you will not have to show me work for that, because it is possible for you to go directly to the answer it is possible to go directly from this down to the answer if you use the formula. I did not teach the formulas this year, but I did give you resources so that you would be able to access like how to do it with the formula. So just make sure that if you're going to use the formula that you do know how it works. All right, I did it again where I clicked onto the next slide. Hopefully I don't do it again. I have to re-record a chunk of this. So for this next one, let's just go ahead and do it. I hate it when I do that, and then it makes breaks on the next slide, but whatever. All right, so we're going ahead and graph it. And what you notice happens this time is that you don't get that nice integer. And that just creates a couple of extra steps when it comes to figuring out what you need to divide by. So 2.5, we're going to dump that in, okay, to Desmos, and it will convert it over to a fraction for us. So it does give us that 5/2. So where you have that root there, we actually want the fraction there, not the decimal. All right, so let's see if I can do this correctly. Good. Okay. So on this one, we have x is equal to 5/2. And what we want to find out is what is the factor that gave us that particular root. Well, you can tell by x is equal to 5/2 that there's division by 2 in there. And so to go weaving your way backwards, you know, that came from multiplication. So what we're going to do to figure out this factor is we're going to multiply both sides by 2. Now, looking just at that, okay, 5 divided by 2 times 2. Division and multiplication undo each other. So if I take a 5 and I divide it by 2 and then I immediately multiply it by 2, I should be left with a 5. Now, because that's an equation, you cannot just multiply the right-hand side by 2. If I multiply the right by 2, I have to multiply the left by 2 as well. And so we get 2x. Now, if I come back over here to Desmos, okay, so if you're like, I don't know, Miss Taylor, that seems dodgy, okay, if I do 5/2 and multiply it by 2, okay, notice that Desmos backs me up on this. It says, yeah, that's equal to 5, okay, so that's just kind of backing up the reasoning on that. That was a super weird sound. Hopefully everything is good. Okay, and now to get the 0, we would need to subtract the 5. So 2x minus 5 is equal to 0. And that's the factor that we're going to be using for our division. So let's set up our division. We have a cubic, so we will have 3 columns. And this time we're going to be dividing by 2x minus 5. Oh, sorry, over there. It's still a cubic. And so this will be 8x to the 3rd. What times 2 would give me the 8? Well, that would be 4. X times what would give me x to the 3rd? That would be x squared. 4x squared times -5 is -20x squared. And as before with the last one, there's no middle term. There's no x squared term, and there's no linear term. There's no x term either. And so that makes things very nice in the middle here because we know that we just need the opposite. So that would be, that's a squared. Okay, squared. So hopefully you don't have me on mute. I understand if you do, but you're not supposed to. So 2 times what would give me the 20? That would be, 10? And then x times x would get me the x squared. 10 times -5 is -50. And of course, that'll be -50x. And then that would have to balance out with a positive 50x. 2 times what gives me the 50? Well, that is 25, and then the x would be taken care of. And then 25 times -5 is -125, which matches. And we knew that this should divide evenly with no remainder. Make sure that you actually state your answer though. So the answer, because this is a factoring problem, you need to state it as factors. So 2x minus 5, and then my other factor is the 4x squared plus 10x plus 25. And again, there is a way to do that without doing any middle steps. Just make sure that if you are going to use that method, that you do understand it. There's a cat here who desperately wants to learn algebra 2, right? Yes. Okay. Great. Fantastic. Moving on. Nope, can't move on. Just kidding. I have to stop the recording again. It's okay. Right, the next two problems are factoring by grouping, and I intentionally made these problems more challenging. Now, make sure that when you're factoring that you factor completely. This means that you get all of the necessary factors out, and I am going to review this using the area model. So we have our area. Here we go. We're going to put x to the 7th because the highest exponent would go in that upper left. Your constant would go in the lower right. And you can actually put the other two wherever you want. But I have typically, in all the ones I've done, I'll put the next highest one down below. And then this would be the x to the squared. X to the squared. And now we have to do a GCF factoring problem, okay? Just GCF factoring in one direction. You can pick any direction you want. I would avoid negatives. So I would start with either this position or this position because it is highly unlikely that any of those are going to be negative, okay? Now for my purposes or just my preference here, I think I'm going to start with factoring in this direction just to avoid the negative as well. So in that upper left, I have 7 x's. X times x times x times x times x times x times x. And in the bottom one, I have 4, and then I have 5 x's. So if you were to look at that and say, well, what do they have in common? They would have 5 of the x's in common. And so the GCF in this direction is x to the 5th. And from that point on, you can do the whole rest of the problem using multiplication. So if you have 7 x's, 5 of them are up here, what had to be multiplied in over here to get you those 7 x's? Well, that would have to be 2 more x's. So that would be x squared. And then down in the lower left, x to the 5th times what would give me 4x to the 5th? Well, that would be 4. And then x squared times what gives me negative x squared? That would have to be a negative 1. And then you can check right here, positive 4 times negative 1 is negative 4. And so my factors are x squared plus 4 times x to the 5th minus 1. Ta-da! Next one. Here we go. And this one we have x to the 3rd, 3x squared minus x and minus 3. And doing a GCF factoring, I'm going to do the same thing just right there just to avoid that negative. So I have x times x times x, x to the 3rd, and then 3 times x times x. So what do they have in common? They have the x squared in common. X times what? Wait a minute, that wasn't right. X squared times what would give me x to the 3rd? That would be x. X squared times what gives me 3x squared? That would be 3. And then x times what gives me negative x? That would be negative 1. And then you can check that lower right. 3 times negative 1 does give you negative 3. So my factors are x plus 3 and x squared minus 1. But remember what I said. You have to get it completely factored, and that is the difference of squares. So we do need to get to the point where we can recognize when we're staring at the difference of squares. You do need to know your perfect squares. So you have like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so forth. Like I mentioned earlier, typically on a test, we're not going to give you super huge problems because that's not what we're trying to assess. So you can probably expect it to be something fairly small. Now, when I go to write my final answer, though, I keep the x plus 3. And then remember that your difference of squares factors into conjugates, and you essentially need the square root. So take a look at this. Make sure that you are clear on this. So x squared factors into x times x. You should not have more x squareds down here. Okay, this line right here follows from the line right above it. So the x plus 3 comes down, and then the x squared minus 1 is splitting up. So you shouldn't see x squared minus 1 and then another x squared minus 1, because then you're just adding something in and you still have the difference of squares, okay? And then the square root of 1 is 1, and of course your conjugates mean that you have the plus and minus of the same thing. That is not something that I can keep going back and teaching and teaching and teaching and reteaching as though we had not seen it. Like, so that has been seen. If you are still shaky on that, you're just not sure why it works, you need to see more examples, please let me know. Okay, I might even be able to link into this video, a review video that has difference of squares in it that will give you more concentrated review on that topic, but that's not the topic that we're reviewing in this. Now, hop back over to this other problem for a second, okay? You might look at this and say, oh, that's x squared and that's a perfect square, and that's 4 and that's a perfect square. But remember that this is the difference of squares, which means you have to have subtraction there. This one is the sum of squares, and that cannot be factored, at least not with real numbers. This is a difference, and it's true that 1 is a perfect square, but x to the 5th is not a perfect square, and so this cannot be factored further. So this one you need to stop, this one can keep going, and you do need to make sure that on your test you know the difference between the two. Oh, we are recording. Okay, good. I had to stop that stupid like clicking ahead. It actually affects the next like 2 slides after the slide where I make the mistake. All right, so on this problem, there are 4 copies of the graph shown below. On the first, highlight where it is increasing, highlight where it is decreasing on the second, where it is positive on the third, and where it is negative on the fourth. So what this is just assessing whether you know that vocabulary, okay? And so I'm going to go turn on my little highlighter here. And increasing means going up from left to right. So that would be from here to here and then from here to here, okay? That's where it's increasing. So as you are tracing this from left to right, it's going down, 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 down. Right here, it starts going up. That's literally the definition of increasing. Now it's going down, 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 and now it turns around and starts increasing again. Okay, so that's your increasing. On the second one, highlight where it is decreasing. Well, that would be from here, and then it would stop when it got that right there. And then it would be increasing for a little bit, and then decreasing right in here, and then increasing again. So decreasing, 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 decreasing. When it hits that bottom point, it would be increasing right in that little chunk, and then decreasing and decreasing, and then it would be increasing again. To be positive means above the x-axis. And I think one of my classes this year, in your notes, I had that backwards, and I apologize for that. I don't even know what like brain blip I had when I said that. So there is one of my class series this year that has something wrong in your notes on that. But above the x-axis is here, and then this little hump right there, and then that. So just kind of tracing it where positive, 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 then negative right in here, positive, positive, and then negative again, and then positive. And then the last one asks us to highlight where it is negative. So that's going to be right here and right here. Okay. And I think I just went through that when I did the positive. So that highlighting is intended to just assess whether or not you understand the vocabulary. And you will have a couple problems on your test where you need to highlight. And that's all, like, you need to highlight it, and you'll be asked to highlight one of those 4 things. I think there's actually 2 problems like this. So there'll be 2, but you'll have separate graphs, and you'll need to grab. You can do it with your pencil. Honestly, you just need to visually show me that you understand what those words mean. And then that'll be followed by a question that says state the interval where it is increasing, decreasing, positive, or negative. So on the review guide, I put here, if you are asked to state intervals, be sure to use only x coordinates, okay? And always move from left to right. So no matter how you want to do this, like what you're doing, like you're always going to move like this over the graph from left to right, regardless of the shape of the graph. And then you're only referencing those intervals using your x coordinates. Now, this is put on here because I know when I photocopy the study guide, the little grid lines here are not going to show up. And so I wanted to provide everybody with the actual function that I used to generate that so that you could put it on Desmos and be able to see it. So that's the only reason it's on there. But this is the function that goes with all those graphs. So here we're asked to state where it is increasing. So remember, we're only looking at x coordinates. So I'm looking at where it's highlighted. The x coordinate okay, I don't want to go back and redo that again. So I am going to do this because I genuinely don't want to. I had too much explanation on that last slide. So, okay, on that last one, we were looking at this interval right here and then this interval right here, okay? And this x coordinate was a -1 and this x coordinate was a 0. And so where it is increasing, so if you're following along at home, okay, and you are writing this out and you have this beautiful notebook, okay, just roll with me here just because I had too much on there to go back and re-record that whole slide. And then this starts at the 1, and remember that that's your positive infinity. So to state where it is increasing, it increases from -1 to 0, and then is decreasing for that little bit, and then it starts increasing again at the 1 and going to the infinity. You should not be using y coordinates, and you should always be moving from left to right across that graph, okay? So pause the video if you need to, and I'm sorry about that. There's just, like, if I don't even know what I was doing. I hit on the slide. It's a thing. All right, so I am going to erase this, so you won't be able to, like, you'd have to rewind the video to come back to it. So pause it if you need to, because I am going to erase that. Well, maybe I don't have to. Let's move on. Key fact: complex roots, zeros, or solutions always come in pairs, okay? So there will be some multiple choice questions on your test that involve choosing possible solution sets for things. So make sure that you're never, ever, ever picking something that has one complex root or one imaginary root or solution, depending on whether you're talking about a polynomial graph or an equation, okay? Because they always come in pairs. And the other thing you want to remember is that the number of roots or the number of solutions is equal to what's called the degree of the equation or the function, which is the highest exponent. So looking at question 12, it asks us, how many solutions does the following equation have? So we look at for the highest exponent. So the answer to that first question is 5. Okay, it has 5 solutions. Now, how many of them are real? So now there's like certain things that are possible for the answer here, okay? Because complex solutions can only come in pairs, it's possible that you could have like all 5 of them are real, okay? it's possible that 2 of them could be complex. So that would mean that 3 of them are real and 2 of them are complex. Or you could have 4 of them be complex because they always come in pairs. So it's possible that 1 could be real and 4 could be complex. Here's the deal. You will be able to see the real solutions because they will show up as x-intercepts on the graph. So let's go ahead and turn off my pen. It doesn't want me to turn it off. There it goes. Okay. And open up the calculator. We're going to go ahead and type this in. And I think if you recall from doing this in class, don't put the equals 0 in. Okay, so just leave it as such. And again, this is where participating in class, making sure that you don't have your head down, that you're not just relying on your neighbor to do it, will help, because if you are doing this, like if your neighbor's doing it, your neighbor's getting that lesson and then you're not. Okay, so looking at this, we know that this particular equation has 5 solutions, and we know that the real ones are going to show up on the graph. So let's take a look at the real ones. I have 1, 2, 3, 4, and 5. So that means that this particular equation has 5 solutions and all 5 of them are real. Now, if you could only see one of them, it would mean you'd have 1 real and 4 complex. If you could see 3 of them, you would have 3 real and 2 complex. But those complex ones would always have to come in pairs. And so to finish answering the question, how many of them are real? All 5. And what are they? X equals negative 2.074, negative 0.835, X equals 0, X equals positive 0.835, and X is equal to positive 2.074. Now, if you were to see this, now I made this up, for the review. If you were to see this on a multiple choice test from like the SAT people or whatever, probably those answers would be in fraction or radical form. Okay, it's unlikely that you would see something that messy. All right, it just is unlikely. And you could always do a conversion. So you would write down the decimals on your scratch paper, and then you would take the answer choices provided in the answer choice options, and you would just figure out, like, take the square root of, I don't know, 7 and just see if that matches any of your decimals. Okay. So you could tackle it that way. The one on your test will not be this messy, okay, but that doesn't absolve you from knowing what you need to look at. Okay, so that should give you a pretty good review for your test. It took somewhere in the ballpark of 45 minutes. I can't see the clock on the recording right now, and I apologize for that last little moving the slide forward. It just it happens. If you watch enough of my videos, you know that it happens. It comes from like touching my touch screen in the wrong spot. Okay, as always, let me know if you have questions, and hopefully you will be well prepared to just absolutely ace your polynomials test.